Now that we're done with the interesting stuff, let's get ready with to hear boring stuff. Okay, so good evening, everybody. I hope you're having an enlightening time. My name is Łukasz, and I'm head of mobile here at SwingDev. I'll be talking to you today about our mobile development process. I'm afraid that given our allocated time, we won't be able to get into much detail, but don't hesitate to reach out to me directly after the talk, or via social media, and I will share the details on the last screen of my presentation. A little bit of background. I started tinkering around in Pascal and assembler around the 6th grade, then got my first commercial project in the 7th grade. Fast forward to 2005, I started developing for Symbian, J2ME, Windows CE, then iOS, and finally Android. I became SwingDev head of mobile in 2016. Since then, I was helping out our awesome team to develop a numerous application for both iOS and Android. Our team changed over time, but currently consists of 2 Android developers, 3 iOS developers, and me somewhere in between. Other team members try to cross to other side as well as much as possible, because we strongly believe in cross-pollination of ideas between Android and iOS. Okay, so let me try to briefly introduce you to the topics I'm going to cover today in my talk. We'll start off with an overview of our process. We'll see how it all works from the bird's eye view, and then we're going to cover each aspect once at a time. We'll go over Scrum, code revision, continuous integration, continuous deployment, and finally I'm going to share with you what we hope to achieve and add to our process in the months to come. Let's start with the overview. Usually we have 2 or 3 developers in each project, even in the smallest one. It increases amount of context switching, but this way more team members retain knowledge of the project and really own the projects more. We try to have one developer develop project and only others do code reviews, but still being developers in other projects. But it didn't go that well, because usually with a lot of their plate, they couldn't commit to really be in that project and all the code, so the code reviews weren't that good. One developer, though, is usually elected to be a technical leader in each project, and this technical leader usually spends the most time in this project and contacts the client the most, and he usually knows the ins and outs of the project the most. We accommodate our client needs, but usually we are able to stick to our own solution when it comes to process. And this consists of Scrum, GitHub as a code repository, pull requests and code reviews. These are mandatory regardless of the project size. Continuous integration and continuous deployment with bitrise, Fabric for actual deployment. Let's start with the Scrum. We don't follow the Scrum to the book. We usually take what we feel and that helps out the process, and we omit what does not. But we have daily meetings of the whole team. We thought about splitting it up into iOS dailies and Android dailies, but our team is so small and many of us are cross-platforms, so we decided that we can have input in both platforms, and we are still able to keep it under 10 minutes. So we think it's the best. It was a good idea. Yeah, sorry, too far. We do have plannings, reviews, and retrospectives. We have 1-week sprints. We consider 2-week sprints, but usually we have like a 3 months long project, and with 2-week sprints we wouldn't have enough sprints to keep really good control over the project. We like when clients are part of the sprint review, so we usually invite them every week to watch us demo the changes during the sprint. And we use JIRA for task management. On JIRA, we try to keep it as simple as possible. We only usually have 4 columns. It's a backlog, in progress, QA, and done. And developer, the column in progress means everything from since taking the project, the task for development until pushing it to QA. So all the internal code reviews, are still in progress because we think that code is not done until the code is like done, finished. It can be not tested yet by the QA, but we do internal testing as well, like developers. But this single column in progress reflects that idea that code is not done until it's not done. So we try to split tasks to be no longer than 1 day. If any task is longer, then we really try to split it up into smaller tasks. And we don't pre-assign tasks to developers at the sprint planning. Usually we just take the task during the sprint whenever we feel it's ready and we want to take this task. We never say this task is going to this developer and this one is going to this developer. Developer feels like implementing this task, it takes this task, or not, then he takes another one. Also, we invite clients to our JIRA as well, so they are able to watch the sprint status even during the sprint. And now to the branching scheme. We adopted the feature branches scheme with 2 fixed branches, master and develop. In the develop branch, we work on a daily basis, and we start feature branches from it, and we merge feature branches to it. Master is kind of release branch. We push the master to release the code to the client. You can think of master as a production branch and the develop as work in progress branch. We do have some naming rules when it comes to feature branches. Usually the name starts with the prefix. It's F for feature, B for bug, and I for improvement. Then we have a story number or any bug number from any task system. And at the end, the short name or description. So, for example, names could be master, develop, F342 fixing landscape view, or I6334 bootstrapping fastlane. We prefer merging feature branches to develop as soon as possible, even if they are unfinished. More on this on the next section. We also tend to do code reviews even for configuration changes. We are disabling direct merging to develop in each project. Usually we don't create release branches. Being a software house, we rarely have opportunity to support application for a longer time, and in the rare cases that we do, we usually fix all bugs in the develop branch and release those fixes in the next version. Code review is a must at SwingDev. Apart from initial bootstrapping, almost all the code gets merged to develop via pull requests. And also the code review is the perfect opportunity for sharing knowledge, growing and discussing good practices. We usually develop good practices on 2 occasions. First one, whenever someone feels stuck and raises his problems, for example, in a daily meeting. And the second occasion is in the code review. That's why we feel the code review is so important for growth, both reviewer and reviewee. We also obviously don't have any hierarchy in doing code reviews. We just create pull requests, and anyone who has some time and capacity gets to reviewing it, be it a junior or senior, it doesn't matter. We have only a few rules when it comes to creating PRs. The most important rule is create pull requests often. We know that creating pull requests or reviewing pull requests takes you away from the very precious and important thing you're currently working on, and it's not the most interesting thing to do. So we try to keep it as small and as digestible as possible. As I said, even if it means that unfinished features get to the develop branch. Unless the only thing that is required is that they don't break tests. So because it will break our our continuous integration and will cause that the pull request will not be able to be merged to develop. But other than that, we can get unfinished features in develop. Another important rule that we like is that when you create PR, if you're making UI changes, then attach a screenshot of the changes you made to the pull request. And if you have, then try to attach link to a Zeppelin file or a link to a Zeppelin or InVisio or any other design tool that you're using. This way, developer can easier check your UI changes if it's what a designer intended you to implement. We also tried out the comments in pull requests, the checklists in pull requests, but we don't have any definite opinion on them. We also have a couple of rules when it comes to reviewing pull requests. First one and most important, don't be a jerk. We are all humans, so let's treat one another with respect. It's the most important. Another one, be diligent. When you get to reviewing, do the review, don't skim over the code. Really try to find those bugs and problems with the code. And third one, mind the business, which can be rephrased to it's about the app, not about the code. So the problem here is that often, or even more often than not, developers really stick to their ideas of the proper code, even if it means getting late with the code, or application may not even work, but the code must be perfect. It's not like this. We prefer when the code follows the app. So the most important thing is working app, then the proper code. I often remind everybody also that don't get upset if you get negative comments. It's like those are only someone else's opinions, so you should treat them as such. Your code is not your child. You don't have to really be. It doesn't say anything. So getting negative comments about your code doesn't say anything about you. So being open, honest, and modest helps a lot in team setting. After a reviewer accepts a pull request and CI gives it a green light, creator of the pull request can merge it to the develop. Let's now talk about the CI. We use Bitrise for our continuous integration needs, and it works as follows. After a pull request is created, Bitrise receives a webhook from the GitHub and launches a test workflow. When the workflow ends, it notifies GitHub of result, either accepting or rejecting a pull request. Each subsequent commit to the branch which has outstanding pull requests triggers another test. Then reviewer reviews the pull request, and if both reviewer and Bitrise give it a green light, then the merging is enabled, and the developer can merge the code. Bitrise is very easily configurable, and we use it extensively. It has a free tier too, so it's easy to test it out if you feel like it. If you feel like trying it after the talk. Actually, after adding project to Bitrise, it automatically sets up the test workflow. We're using Fastlane for iOS and the Gradle in the Android apps. Both technologies are supported and automatically discoverable by the Bitrise. In order to create a CI workflow in Bitrise from scratch, you only have to do two steps. First one, create a workflow that launches your tests. For example, launching Fastlane test or Gradle test. Where's the pointer? Okay, it's in here. So this is the workflow. This is all the steps required. But actually, those steps were automatically created by the importer, Bitrise importer, and this step is not really required to do anything with steps. Certificates and profile installer is also not required because we're using Fastlane. So really, if you would create this workflow by hand, you would only need to create those two steps at the beginning and those two steps at the end. Second required action is to create a trigger that will launch your workflow. And you have three options here. The workflow can be launched by pushing to a specific branch. For example, here we push to any branch causes a workflow to be triggered. Also, workflow can be triggered by creating or updating a pull request or pushing a specific tag. And here in our example, we can see that pushing to any branch launches primary workflow. One thing that is problematic, though, in this setup is that creator of the pull requests only gets notified about the existence of the errors, not about the errors themselves. So fortunately there's another tool called Danger. It's a very extensible Ruby tool that can be used to check pull request metadata or code statistics, and it's very easy to integrate into Bitrise. We use it in a very basic way, just to test if the pull request is not too large, so the code change must not be larger than 500 lines, and also to convert the build results from Xcode to comments in pull requests. This sample here is just taken from the pull request itself. It's just a comment made by the Bitrise with the SwiftLint errors, and amount of tests executed, and we didn't have any failures. Had there been any failures, we would get specific information in here about those errors. After the sprint is done, we usually want to deploy the application to the client after each sprint. We like when client is aware of the status of the project since the beginning of the project, even after the first, maybe not the first one, but the second or the third sprint. To do this, we again employ Bitrise. This time we create a continuous integration deployment workflow, a continuous deployment workflow, sorry. In general, a continuous deployment pipeline consists of two components. First one is application builder, and the second one is deployment platform. As mentioned before, we use Bitrise for building apps. Our deployment platform of choice is Fabric. We've been successfully using it for many years, and it supports groups and has a nice integration with Fastlane too. To additionally simplify our iOS setup, we use Fastlane, including Fastlane Match for application signing. This way we can build apps from Bitrise and directly from the developer's command line with just one simple command. Our Fastlane setup is a bit complicated and would be worth a talk of its own. But most of the complexity comes from the fact that we want enjoyable Xcode experience, but also easy deployments on the continuous deployment server and from the command line. In our Fastlane, we have 4 types of lanes. This is a test lane, environment change lane, release lane, and utility lanes, used only by the 3 above types internally, not to be used directly. The first kind of test, the first kind of lane test, only runs the scan, which in turn launches Xcode clean and test command. Actual command is a little bit more complicated than this, but it's automatically created and launched by the Fastlane, so I've reduced it for simplicity. Switch to family of lanes, updates info plist file and provides additional config settings for the Xcode with the proper values for selected environment. It updates bundle ID, project name, provisioning profiles. It also updates selected environment Swift file. This file contains a currently selected environment. It can be dev, QA, production for us at least. Environment is an enum that contains all environments that we support. Environment contains a spec variable, which in turn holds specification for each environment. Here in our sample, we can see the base URL for API calls, logging enabled, so it's a setting for just logging, and App Store link. The last and directly usable type is to release the app to the client, and it does the following. First, it gathers the gets the build number from Git, and it does so by computing or just fetching a number of commits in the current branch. Then it gets the last Git tag, and it calculates a version from it. That it gathers a changelog since the previous version or previous release. Then it sets up provisioning profiles, certificates using Fastlane match. Then builds application and packages into IPA file, and finally publishes it to Fabric. Now that we know how our Fastlane setup works, let's get back to general deployment workflow. Deployment looks as follows. We merge code to the master, then we add tag. Depending on required environment, it can be dev/version code, QA/version code, or production/version code. So, for example, dev/0.3.4. This tag is set up to trigger proper deployment workflow in Bitrise. Bitrise launches Fastlane release lane or Gradle task appropriate for this environment, for this tag prefix. Then we finally publish it. Then we finally publish it to Fabric. And this publishing is done by Fastlane and by Gradle. Okay, so now that I talked to you about how things are, let me briefly talk to you about how things are going to be. We are constantly improving our process, and we're working on a few tools that I want to talk to you about right now. The first one is called Renovate Bot. Renovate Bot is an open source tool that automatically checks for updates in your dependencies. If an update is found, then it's applied, the tests are run, and if everything is correct, then it creates a pull request. Renovate can also be configured to apply those changes to your develop branch or to any branch instead of making pull requests. So if you feel confident in its behavior, then you can change the configuration to directly apply its changes instead of creating pull requests. And this tool is very widely used in the JS community. Unfortunately, it doesn't have CocoaPods integration. It seems that development of such integration started, but they only updated the README file, so we started working on our own integration. It's work in progress, and once it's ready, we'll publish it. So another tool we're working on is a Bootstrap. We've noticed it sometimes takes us a couple of days to bootstrap new project because there's a lot of work setting up repos, Xcode, Fastlane, match, provisioning profiles, environments, Bitrise, Fabric. There's a lot of stuff. So we've developed a Python tool that helps us all with all those tasks. It's not yet fully functional too, so once it's ready, we'll publish it as well. And that's all. Thanks for your attention. If you have any questions, then raise your hands. We're going to throw this lovely microphone at you, or to you, maybe. And yeah. And if you want to reach out to me after the call, then I'll be somewhere here, or you can use Twitter, or just find us out on the Facebook or anywhere else, and post a message. It will get to me. Okay, so questions.
Questions, yes. If we
Bartek?
Oh, sorry. I went straight for the online questions.
Okay, so I have a question.
Can you put the mic closer to
Do you use any tools for translations in your projects? How many languages do you support in your projects?
Well, unfortunately, because maybe it's more boring, most of our applications doesn't require any translation, but we're using SwiftGAN, so it gives us, Marek showed it, and it gives us automatically.
I have another question, because regarding the Android part, how do you support, how hard it is to support different build variants in Android? Should that Bitrise supported good or not?
Well, from the process point of view, it doesn't really matter because I don't think I've showed this screen, but when you configure Bitrise, for example, you just tell it to launch a specific Gradle task. So you have those variant settings in there.
And if I can third question.
Yeah, sure.
Do you have some libraries which you share between your projects? And if so, how do you share your code between projects? Do you use submodules from Git or no?
Well, in iOS we use CocoaPods because we do not have any internal libraries, so we use only the public ones, and we use CocoaPods in iOS and just normal Gradle dependency injection in the Android.
Okay.
Okay, thank you. All right, so thanks again, and see you at the workshops.